Hello everyone, how are you doing? Is the sound good? Great. We're glad to have all of you here today. My name is Alexandra. I'm DevRel with FHERMA, Developer Relations. Let's give a couple minutes for the late birds. And for now, while we wait for them, I suggest we take a look at these QR codes. Let me put up the presentation again. So here are our website, our FHERMA challenges platform for FHE challenges, and our social networks where you can reach us, the X account and our Discord server. So if you're not there yet, please come in. We'll be happy to have you. If you already have any questions, you can start jotting them down. But I would like to share our plan for today with you, since I prepared something to talk about, to answer some of the main questions. Yep, it works. So that's our plan for today. I'll tell you a little bit about our FHERMA challenges problem. I'll talk about polycircuit FHE components library and how we build it from the winning solutions from FHERMA. I'll cover our ongoing challenges, and we'll have time to answer all your questions. Okay. Oh yes, I see your comments. Thank you. Okay, so let's start with FHERMA, our main topic for today. So yes, the website is fairmath.xyz. I'm sorry about the logo. Ah yes, now it's not covering. Great. The main idea behind FHERMA is that we want to build an open source library of ready-to-use FHE components for everyone to use them to build their applications. So FHERMA hosts FHE challenges of various difficulty. For now, it supports two FHE libraries, OpenFHE and Latigo, and there are bounties from $2.5K USD. And the first round of challenges is already completed. It's already in our polycircuit library on GitHub. So we already have some winners and we already paid some bounties. About our polycircuit library. Oh yes, now the link is overlapping. Let me get it to you, let me take it because the StreamYard's logo is covering the link. I will post it to YouTube chat right now. So right now we already have an initial version of polycircuit library with 3 components from first round of challenges. They are published with a consistent interface, but everyone can improve them. The library is open for contributions under Apache 2.0 license. And soon, like in a month, we'll have more components for polycircuit, as our current round of challenges is ending up on June the 5th. And on June the 15th, we'll have our results on which component is best and the most performant. Okay, so let's dive into the challenges that are open for submission right now. On FHERMA, we have 2 types of challenges. A white box challenge, where you have to publish your code, not exactly publish, submit it to our platform, and we're not showing it to anyone yet, but we might check it. And for black box challenge, the only thing we need from you is the resulting ciphertext. So we will only need the code from the winner. And just to check your solutions, we only need your ciphertext. As you can see, the deadline for this challenge is in less than a month. And we already have some quite good results for OpenFHE. It's 94% accuracy For Latigo, it's a little bit lighter, but still there's room for improvement, and we hope to see 100% accuracy. There's still time for submissions, so give it a try. Cypher 10 challenge is also a white box challenge. So, no, Riddle was a black box, so this is a white box. We need you to submit your code. On the challenges page, you might find extra instructions on how this package should look like. Submission deadline is also June the 5th. And the supported libraries are also OpenFHE and Latigo. I'm sorry, current best results are shown in black for some reason. Okay, so I will just spell them out. For OpenFHE, it's 10%, so not a lot of accuracy yet. And for Latigo, there are none solutions that passed the accuracy test yet. It doesn't mean that there aren't any solutions, just nothing that passed the threshold for accuracy. We also have a parity challenge created by IBM Research. And today we have with us Chaim from IBM Research. And I would like to invite him to tell us a little bit about this challenge and motivation behind it. Hello, Chaim.
Yes, hello. Can you hear me?
Yep.
Excellent. Yes, so this challenge is a white box challenge. That means that you need to submit your code. And so then the encryption scheme is, it's supposed to be to run over ZKKS, either over OpenFHE or over Latigo. Yeah, the submission deadline is in June 15th. And the bounty for the winners is $500. $5,000 split between two winners. Yeah, so the challenge here, I will show a presentation soon, but the challenge here is to or maybe I'll show the presentation now. Can I share my screen?
No, I'm sorry. I think this software doesn't allow it.
I see. That's a shame. Okay, never mind. Okay, so now just a second, sorry.
If you have any questions about this challenge,
maybe now?
parity, let me check. Oh, yes, I can see your screen now.
Oh,
yes.
Excellent. Okay, so okay, so the parity challenge. Yes, so the parity challenge is as follows. We are given a message M, and obviously being encrypted with ZKKS, there's some noise added to it. So we have M plus E, where E is the error. And we know that M is an integer. I mean, this is what the system does. M is an integer, it has some noise, and we want to compute M modulo 2. That means the parity bit, the LSB, this significant bit. So for example, if we have 43.003, then it should output 1 because, well, 43 is odd. And if we have 133.994, it should output a 0 because this is actually 134 and the error is minus 006. So obviously there should be two parameters to this challenge where we set it in the challenges page. One is what is the error added to the message, that is M plus E. So what is the bound on E, on the E of the input? And the second parameter is what is the bound on the E at the output. So obviously, being CKKS, we will not output 1 or 0. It will be 1 plus some noise and 0 plus some noise. And we the challenge. So the parameters of the noise bounds is given in the challenge page. And let me give you some motivation why this is an interesting challenge, why parity is interesting. So one thing you can do with parity bit is bit decomposition. So suppose you have an integer m, and suppose you know that it is 8 bits. Again, this is your system, like maybe it's cipher10 and you have a ciphertext that has the classification of the digit that is encoded in the yes.
Sorry for interrupting you. We get messages that your presentation slides aren't working, like they're not changing. Can you try and see about that?
Oh,
it's just slide the parity challenge. Oh yes, now it's.
Now you see. Okay, so I see. Okay, so
probably,
it happened.
Yes, you should show it again.
Because I went to present the slideshow. Okay, so yeah, so the challenge is this. So we are given m plus e, and like this was the example 43.003 and 133.994, and should output 1 and 0. Sorry. Okay. Yeah. So you can decompose an integer. So suppose you know that this is an 8-bit integer, you can extract the parity bit, the LSB, subtract it from the message, divide by 2, and repeat the process 8 times, and you have the bit decomposition of the number. So why is bit decomposition interesting? You can do some interesting stuff with bit decomposition. For example, a sign function. If you can efficiently extract the bits, sign functions can be more accurate. For example, you can compare the bits of the two numbers that you want to compare. Another motivation is one hot representation. So what is one hot? Suppose you have a number between 0 and 7. Then the one hot representation of that number is an array of 8 slots. So 0 to 7, there are 8 numbers. 8 slots, and all the slots are 0 except for the slot whose index is the same as the number that we're encoding. So for example, here, if m is 5, so the one hot representation is going to be 0, 0, 0, 0, and 1 at the 6th place, because we start at 0. So this is 0, 1, 2, 3, 4, and 5 equals to 1. So with bit decomposition, we can compute the one hot representation efficiently. For example, take here the bit decomposition of the message, be it B, B1, B0, B1, and P2. So the first slot is 1 minus B2 times 1 minus B1 times 1 minus B0. And you can actually compute all these multiplication of all these products with only n multiplications. Here n is 8, with only 8 multiplications, because you can take advantage of some products being repeated. So for example, 1 minus B2 times 1 minus B1 is repeated here, and actually only here and here. So you can take advantage of these repetitions. So why is one hot interesting? I mean, it's interesting by itself, but why is it also interesting? Well, for example, you can implement a lookup table access with it. So suppose you have an array A, and M is an index, and you want to compute the mth value in A, then you can compute the one hot representation of M, be it H, and then return the product of HI times AI and sum over all the products, and you will get exactly the mth slot in A. So why this is also interesting? So as we mentioned, so CKKS obviously, you know, adds noise to the message. So if you take a message M, you encrypt and then decrypt it, you will get not M, but M plus some error, and the error grows with the computation. So eventually, so obviously some algorithms are self-correcting. For example, gradient descent. It has some negative feedback, and if you slightly deviate from the plain text value, then it will self-correct in the next iteration. But what if the algorithm is not self-correcting? Can E be reduced? And the answer is, well, obviously no, but in some cases, yes. In some cases, when we know that M is an integer, we can use the parity, we can use the bit decomposition to reduce E. That is, we can have some function that gets M plus E and returns M plus E prime, where E prime is smaller than E. This is something we published in JOC, Journal of Computation in Cryptography. We called it Bleach. So the idea there was to take M, that we know that is an integer, decompose it to bits, reduce the error on each bit, and then reconstruct M again from the bits. And this can perpetually go on forever. If we know that M is integer, that the computation is over the integers, we can go on computing and infinitely going computation over CKKs. So yeah, just to summarize it. So we have parity. We can perform bit decomposition. With it, we can either reduce error over an integer message, or compute the one hot and implement lookup table. But everything depends on having a good parity function. So this is why parity is very interesting to us.
Okay, thank you, Chaim. We'll get back to you a little bit later if there will be any parity questions. For now, let me continue. Okay, so as you can see, there are pretty good results already for this challenge. For OpenFHE, it's a little bit lower than 3 seconds, and for Latigo, it's a little bit higher than 3 seconds. You still have time for like a month. Yes, the deadline is 15th of June, so give it a try. I think we can reach a better result here. Let's move on to the newest challenges that we have for you. We've recently opened an FHE EVM track. This track's purpose is to collect components that can be used for building an FHE EVM. So this track's purpose is, as with FHERMA, a collaborative approach to building something great. In this case, it's FHE EVM. The first challenge in the track has already started. It's a left shift challenge. You can see it in the track in the tab challenges. And new ones will be open quite soon. I also wanted to mention that we will be participating in ZK Hack Kraków. It's a hackathon which is operated live on chain, as you may say. It will be in Kraków. And let me get you the link. It's zkkraków.com, yes. I'll post it in the YouTube chat. And we'll have 2 bounties there. It will be FHE bounties on ZK Hackathon or ZK Hackathon. Yes, I know, but we discussed it with the organizers, the people who manage this event, and they were up to it. They said that it might be an interesting challenge for them and for us too. So let me share with you also our bounties for ZK Hack, but it's only a live hackathon, so you have to register for it and you have to be present in Kraków, in Poland, for this weekend from 17th to 19th of May. Okay, yes, I think I've posted all the links that I needed for the website and for our FHE bounties for this hackathon. I would also like to mention that we started to develop an OpenFHE Rust wrapper. And in this hackathon this week, ZK Hack challenges will be the first challenges to accept submissions using this library, OpenFHE-RS. Okay, and now I think we're ready to answer some of your questions. Let me see the chat. Okay, I think the first question was, is it possible to participate as a group or team using a single account? Well, right now, only these challenges are only for like single contributors, but we plan to implement this feature quite soon. So stay tuned. Soon there will be an ability to participate as a team. Okay, I'm gonna hide this question and go to the next one. How many test cases there will be for ReLU? ReLU is a black box challenge, which means there are first, initially, there were one test case. When the accuracy on it was has reached 100%, we added the second test case. Right now, the accuracy for the second test case hasn't reached a lot. It's like under 80%. If the accuracy for the second test case will be 98% plus, then we're going to publish new test case, a harder one. And for now, we're waiting for the previous ones to be solved. And for ReLU, it's the deadline is 5th of June, so the time to publish your ciphertext of your solution is less than a month. So we hope we'll see some good results in that time. Okay, going ahead to this. Another question from Sash. If I have an idea for a challenge, can I add it? Yes, of course. Our challenges, we have an open challenges with open leaderboards. All solutions go to open source library polycircuit. So, of course, we're open to any contributions that you might have. You can go to our Discord server. We have a channel for contributions. Or you can contact us in any other way that's convenient for you. And we can work together on that idea for the challenge. Probably we might edit. Okay, the next question was, can I take all the prize fund for a challenge, like ReLU so far in all categories? Yes, the prize fund in some challenges, like SciFar, reaches like $10,000. And if your solution is the best in all categories, like in both in OpenFHE and in Latigo libraries, and it scores as the most fast and the most accurate, well, why not? You can take all the bounties if you are the most, your solution is the most performant. If I win, do I have to give you rights to my code? Well, I would like to ask someone from the team, like Nikita, are you here? Can you answer this question?
Yeah, I guess we can. Can you hear me?
Hello, Nikita. Yep.
Hey. Yeah. So we publish all the winner solutions on the under the FHERMA tool license in our open source public repository on GitHub. So I guess the short answer is no. the long answer is it is published and accessible for everyone to reuse it. Like that.
So when you participate in our challenges, you agree that you are willing to contribute your code to open source, that if you are a winner, your winning solution will be published in this library, Polycircuit, under Apache 2 license. Is this correct?
Yep, that's correct.
Okay, then, thank you. I'll remove you from the scene for now. The next question, I think we're going to need Gurgen for that. What will we do if there are two solutions with the same score and execution time? Actually, I don't think that ever happened before, because when I see the leaderboard, it's always a different score or different execution time. But let's hear what Gurgen thinks about it.
Hi, everyone. Theoretically, it's possible, but we try to do it as fair as possible. And if the situation happens, we will make decision if we will see this result. We have committee on the platform challenges. We have separate committee for each challenges. And if we will have two results with the same, two submissions with the same result, we will make decision when the situation will happen. I think it should be clear.
So we were never in this situation before, but if this happens, the committee of challenge, if you go to the challenge page, you will see that there are committee for almost every challenge, will decide who will be the winner. Okay, the next
also,
question,
it's possible to share the prize.
Okay.
So it's not necessary to choose only one winner. If it will be more or less the same submissions, we can share prize fund, or we can select some additional prize. It's possible. We're flexible here.
Okay, Gurgen, can you also help me out with the next question, which is, why do you score Latigo and OpenFHE separately?
It's a good question, and I would like to add some clarification about rule challenges when we show that for OpenFHE version we have more than 90% of accuracy. For Latigo is a little bit less. The reason here also is that for Latigo we have less multiplicative depths. So currently for Latigo version we have 3 multiplicative depths. For OpenFHE it's 4. Why we score it separately? Just because it's quite difficult to score it. It's difficult to score it in a fair way without separation, because there are different implementation, despite the fact that we utilize the same FHE scheme, but implementation is different and it may be not so fair. And this is why we decided to score it separately, just to exclude any unfair and untransparent situation. For the future, we will think about it, and if it will be possible, we will score it in the same way.
Okay, got it. I thought of a question that I wanted to ask myself, like, are we going to add more libraries besides OpenFHE and Latigo? Gurgen, if you're here and available, can you please answer? If not, I can ask Nikita.
Yeah, sorry, which one? What?
Yes, I asked the question from myself. It's about whether we are going to add more libraries, FHE libraries, besides OpenFHE and Latigo.
Currently, we added two libraries. We have demand on. We are working on adding new libraries. And unfortunately, currently, we don't have this information. It depends on a lot of things, but maybe a little bit later, we will publish some information. But again, if someone needs to add some new library, feel free to suggest it in our Discord, and we can add quite fast on our end new library.
Okay, thanks. Let's move on to the next question. When will be new challenges, EVM challenges added? Okay, we've just opened an FHE EVM track. Let me get a link for you so you could take a look. And the first challenge is already open for submissions. Right now, we plan to release about one challenge once per 2 weeks. So stay with us in our Discord and in our X account. We will surely share all new challenges on FHERMA with you. The next question is about IBM's parity. So, Chaim, if you are here, if you are available, can you please answer it? Okay, I think Chaim may be away. Let me try and answer it. Here he is. Okay.
Yeah.
Hello again.
Can you hear me?
Yes, sure.
Oh, okay. Yeah, I was speaking before. Okay. So the question is, will IBM's parity component also go to parity challenge? I'm not sure what that means. You mean if we, if you mean if you can use the parity function that HELayers provide? Yeah, sure. You can use that, but obviously, if you do that, everybody can do that, and nobody will be the winner. The idea here is to come up with something of your own. If what we did is the best, then I'm not sure what I'm not sure that this is the case, but then good job us. But yeah, the idea is here that you will come up with your own solution that are better than ours.
Oh, I think the question was, will IBM's parity component also go to polycircuit to open to our open source library of FHE components?
Yeah, so from our side, then yes.
Okay, great. So once the current round of challenges are finished, they will also be added to polycircuit library. All of them, including ReLU, CIFAR, Parity Challenge, and the FHE EVM Challenge shift left when it will be ready, because as far as I remember, for shift left, the deadline is end of July. So are there any other questions? Feel free to ask questions about FHERMA, about ongoing challenges, about challenges that are already closed, about ZK Hack Kraków and its bounties. I mean, our FHERMA's bounties. There's another question about parity. Will it go to the IBM HELayers library?
So you're asking if the code will go into the HELayers library? I'm not sure that this is legally. I will have to ask the legal team if that is possible. I don't know.
The IBM parity component will be open sourced and under Apache 2 license in Polycircuit library, so you can always get it from there. And if you want to, after the challenge is over, if you want to probably contribute to it, make it faster, more performant, you can always do it in the Polycircuit library.
Yep, that's right.
Okay, is there any more questions? Okay, then I think we're done for today. I think this is our first, but maybe not the last AMA session. Thanks for everyone who tuned in, and hi to everyone who will be watching this later. Again, here are our QR codes with links to our website, our challenges platform, our X account, and Discord server. We're happy to have you. Thanks you so much. Have a nice day or evening.